Evolution of the atomic model. In this video, I'm going to explain the three major experiments that make the contribution for the atomic structure. As I explain, the new model will be updated in this diagram. I'm going to start with J.J. Thompson experiment, then Rutherford experiment, and I will explain the model proposed by Newsborn. This is the experiment designed by John Thompson. He was a British physicist and teacher, and what he did was he modified this glass tube, and he connected this end of this tube with the negative terminal of a battery or cathode, and the positive terminal of the battery he connected with this section, and this section is also connected to those two metal discs with a slit in the center. And the reason why he did this is because he created a spark in this chamber. So that is the electrons that from the negative terminal of the battery, they want to jump to the positive metal discs. And that way, with this slit, he could just visualize just a stream of this ray. So this stream of this ray was passed through straight, and he could spot that when it arrived here at the bottom of this tube, because he coated with phosphorescent material which glows in the dark. One more information is that before he did all this experiment, he removed all the air from this tube with the intention of prevent the ray interact with the air molecule in this apparatus. To determine the charge of this ray, he connected a parallel plates inside this tube and connected, start with the top one with the positive side of another battery. And then he observed something very different. So the ray at this time will bend toward the positive terminal of the battery that we are going to mark as B. At this time, he reverted the polarity of this parallel plate. Now these will become negative and these will become positive. And he observed how the ray is going to behave in this condition. So what he noticed is with the terminal positive here at the bottom, the ray is going to bend toward the positive terminal, glow right here at this portion of the bottom. So he concluded that this ray must be negatively charged because it's all the time attracted to the positive parallel plate. The model of the atom proposed by Thompson based on the results of his experiment consists of a big positive sphere with negative charges scattered throughout this sphere. So this model resembles a dessert in England that it was very popular, is the Planpuri model. The plum should be the electrons. They are embedded in a very big positive dough. The second scientific experiment conducted to explore the atomic composition was a gold foil experiment. Ernest Rutherford was Thompson's student. He constructed his experiment powered by a radioactive material, the radium. This rock emits a positive ray, and to make sure just one stream of ray would be used, he placed the rock in a radiation box shield, possibly made of lead, and he faced this hole to a very thin gold foil. Then he shaped a circular phosphorescent film to observe if the positive radium ray would pass through the gold foil or if it would deflect. After constructing his experiment, Rutherford assigned two of his students, Hans Geiger and Ernest Marsden, to observe the location the radiation ray hit the screen after passing through the gold foil. They observed basically three locations. A, most of rays pass through the gold foil, like it was not even there. B, some rays deflected at small angles. And C, just a few rays bounce back. So those three locations, they were very important to make some conclusions about his atomic structure. Based on Rutherford gold foil experiment, he proposed that when the atom is mostly empty space, proved by A, which most of rays went straight through. 2, there is something solid inside the atom, which was proved by B and C. Some rays were deflected or bounced back. And the third one, there is a nucleus or is in central location positively charged because the positive ray were deflected based on the like charges repel each other. Now I'm going to explain the atomic structure proposed by Newsborn in 1913. What he disagreed with this model in terms of the location of the electrons. So if this model was correct, if the electrons, they were in fixed orbits around the nucleus because they are negatively charged. So what is going to happen is the electrons, they are going to spiral to the nucleus because they will be attracted to each other. One is negative, one is positive. So this model was updated by Newsborn with the following experiment that I'm going to explain. Newsborn conducted this experiment using a hydrogen gas tube like this one. What he did was he wanted to prove that electrons were not in fixed orbits. They were jumping from orbit to orbit. So he wanted to prove also that each orbit requires a certain amount of energy. So in order to jump from one orbit to another, electrons need to absorb or emit energy. And these will be proved by the spectral lines because each color will be represented by a a specific amount of energy due its wavelength and frequency. So what he did is he connected this gas tube to a high voltage and to kind of filter the light in one single ray. So he used a slit to straight this line, and this line passed through a prism, and the prism separate all the light into its components, and then we can see all those lines that he called spectrum lines. Now to translate Born experiment to his model. So let's understand a couple things here. Number one, when he studied the hydrogen gas, he observed some very specific lines that he called spectrum lines, and those lines are very specific for each type of atom. It's like identification or barcode, he called, for this atom. To translate this to this model, what he proposed is that electrons, they are not in specific orbits. They are jumping from orbit to orbit, like electron jumps. So he translates these into energy. In order for electrons change orbits, they need to gain or release energy, because each orbit, they have a specific amount of energy in order to stay there. So by, for example, by going from a higher orbit to a lower orbit, so electrons emit some energy, and that energy is translated into a specific color, because that energy that was given by this formula, 13.6 eV. eV is electrovolt, is a unit for energy. They multiply the fraction of the initial orbit square minus the inverse of the final orbit square. So with this formula, we can quantize the change in energy and convert this energy into joules, from electrovolts to joules. And from this energy, we can apply this energy formula for the light, and using Planck constant and the frequency. So the frequency, once we have the energy, we can calculate the frequency of that jump, and this frequency can be translated to a specific color. So the color could be violet, blue, green, yellow, orange, or red. So for each color, we have a specific wavelength and a specific frequency. So they are in terms of, in this case, nanometer for the wavelength, because light travel as a wave. So wavelength is the distance of a wave, wavelength. So the wavelength or the frequency, which means that the number of repetition of this wave in 1 second. So that gives us the frequency. So each color travels as a wave, and each wave has a specific wavelength and a specific frequency. So we can translate the energy from the electron jumps into a frequency and find the color of light emitted by the jumps. So that's how he could understand how he got these spectrum lines. So to finalize the diagram for the evolution of atomic model, so here is Bohr model, indicating that electrons, they are not on a specific orbits, they are jumping from orbit to orbit to avoid that will fall into the nucleus and collide with all the particles.